My name is Preston Mitchell. I'm the plant manager for Essex Industries. Essex Industries is the vocational site for Mountain Lake Services, where we have an integrated workforce to be able to bring in individuals, be able to offer work as a training tool, to be able to job-ready individuals to work in the community. And to do that, we have an extensive woodworking shop, sewing, packaging, and different kinds of prep work for customers in the area. One of our larger contracts is working with Whistle Pig. That's a company both in the Mineville area and Shoreham, Vermont. We do a lot of packaging, prepping, construction of pallets. And one of the jobs that is unique that we've been doing for some time is applying corks into bottle toppers for whiskey bottles.
My name is Jasmine Olson, and I'm a craftsman at Essex Industries.
My name is Luke McKernan. I'm a production worker for Essex Industries.
First, put a little bit of glue in the center, if I can get it. Take the cork, press it down, make sure it's centered, and put it in here.
Do you have any issues with this process?
Well, every now and then I'll get pains in my arm and I have to stop for a couple days and then I'm fine.
And how many whiskey tops do you do in a day?
Ranges from probably 800 to 1,200.
What you've just watched is an interview with Essex Industries, our member agency in the Career Project. When we began the project, Essex had approached us with the idea of mechanizing one of their jobs to increase accessibility. The job we chose was installing corks into the whiskey tops. 7 months later, we have our solution. Currently at Essex, there's a limited number of individuals who can complete the task of adhering a cork to a whiskey top. The food-safe superglue they use is very expensive, making mistakes costly. The process can also be taxing on the individual working. An employee working on the whiskey tops can produce between 800 to 1,200 finished tops in a day, causing pain in the wrist and the forearms. Our solution is to build a machine that will give the ability to install the corks to more people. With the basis of our solution is a linear motion device that will move the trays carrying the whiskey tops to a gluing mechanism that will dispense a precise amount of glue. The tops will then move to a pneumatic system that will install the corks into the whiskey tops. The whiskey tops will then be carried on a tray that we have 3D printed to fit them. We designed the tray to carry 10 lids, with the possibility of Essex wanting to expand and add another glue and corking mechanism.
We're using a horizontal linear motion system to move the trays, carrying the corks from one station to the next. The system uses a stepper motor controlled by a Raspberry Pi, which is coded to stop when an end stop is triggered. The system will pause for a set time, allowing the tops to receive glue. The system will start again, only pausing when the next end stop is triggered, giving the tops time to receive the corks. The machine will start again and continue until it reaches the end of the system. The machine will stop a final time, allowing the tray to be removed. Once the tray is removed, the machine is ready to begin the process again.
Our gluing mechanism uses a semi-automatic system to control the amount of glue that's released from the syringe. The system uses an air compressor to control the machine to allow the correct amount of PSI to push the piston and supply enough air for the system to run smoothly. From the air compressor, pneumatic tubing runs through a two-way splitter. The first line of the splitter runs through a glue system to the back of the control box. From the control box, there's another line that's connected to the syringe that is full of glue. The syringe is suspended above the linear system, which will carry the tray of whiskey tops. The glue will be released at the press of a button. The amount of glue released will depend on the length of time the button is pressed.
Line comes from the splitter and attaches to the air compressor and runs into a solenoid valve. From that valve runs 2 lines. The first goes into the top part of the pneumatic piston and the second runs into the bottom part. Air enters the pneumatic system, which will extend the piston down. As it descends, it will catch a cork from the magazine. The magazine we created holds 5 corks. The magazine will be triggered by the linear motion system and will use a stepper motor to rotate, moving the corks forward into a tube. The piston will then push the cork down a tube, which will be directly above the whiskey top that is awaiting the cork. After the piston is extended, the electronics in the solenoid valve will retract the piston so it is ready to send another cork.